If you like our video, please like, share and subscribe it. Again, I am here with part 6 of chapter 1 Real Numbers 10th class Maths NCERT book. Today's topic is application of Euclid's division lemma. It's a 3 marks question. Now, the question is, use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. It's a short question. It will definitely come in 3 marks. Now let's discuss it stepwise. Let a be any positive integer. On dividing it by 3, so 3 is the divisor, which I have denoted by an arrow and also by a dot in the last line. Well, in the last line I have shown you the Euclid's division lemma. A is equal to BQ plus R, where here B is 3. So on dividing it by 3, let Q be the quotient and R be the remainder, which is also there in the Euclid's division lemma. A is equal to BQ plus R. Here B is 3 because we are dividing it by 3. Now what is R? R is always less than B. So it should be less than 3 and it should start from 0. Every time it should start from 0, less than B. Here B is 3, which I have denoted you by dot. So less than 3. Start from 0. 0, 1, 2. I am going to use Euclid's division lemma stepwise. A is equal to 3q plus R. The first case will be if R is equal to 0. When R is equal to 0, A is equal to 3q plus 0. Now first case, A is equal to 3q. On squaring both sides, you have to use the step. On squaring both sides, you have to write. A squared is equal to 3 squared will be 9 and q squared will be q squared. So 9q squared. Now that is equal to 3 into 3q squared. Now you will ask me, why did I take 3 out of the bracket? There is a trick. We want it of the form 3m. It is asked in the question that you want the form 3m. So 3 should be common. In this particular step, in 9q squared, 3 is taken common. Whatever stuff is remaining is kept in the bracket. What stuff is remaining? 3q squared. That stuff is kept in the bracket. The main thing is that you have to take 3 outside because you ultimately want 3m. Now m is whatever you find in the bracket, you write as it is. M is equal to 3q squared is in the bracket. The main thing is write 3 outside. Now the second step we are using is here we're going to use R is equal to 1. So A is equal to 3q plus R according to Euclid's division lemma. Now when R is equal to 1, in the place of R you are going to write 1. Therefore A is equal to 3q plus 1. Now case 2 begins. When A is equal to 3q plus 1, on squaring both sides, this step is compulsory. You write on squaring both sides. A squared is equal to 3q plus 1 whole squared. Here we are going to use the identity A plus B whole squared. What is the square of 3q? 9q squared. What is 2ab? 2 into 3q into 1. And the last one is for b squared. So b squared is 1 squared because here b is equal to 1. Therefore, a squared is equal to 9q squared plus 2 3s are 6 q, and the last one is 1 squared, that is 1. again and again. The main part comes now, that you don't make any mistake, don't commit any mistake. You have to remove 3 in the front. In the beginning you have to remove 3 common, put the other stuff in the bracket, and in the last you take 1 common. Now I'll explain you why we took 1 outside. You visit the question again and again. The question says that your answer should be in the form of 3m or 3m plus 1. Here we are going to use 3m plus 1. That's why we took that one outside the bracket. Plus 1 should be in the outside. Don't commit any mistake. Don't put it in the bracket. Many times students put it in the bracket and then also they write 3m plus 1. So that's wrong. You have to remove it outside the bracket. So 2 things you have to remember: 1 outside the bracket in the last, and 3 outside the bracket in the beginning. The remaining stuff would be in the bracket, which will get converted into m. So a squared is equal to 3m plus 1, where m is that stuff in the bracket, that is 3q squared plus 2q. Now the next case, a is equal to 3q plus r. Here, when r is equal to 2, this is the third case where r will be 2. In first case r was 0, second case r was 1, and now the third case r is 2. When r is equal to 2, a is equal to 3q plus 2. In the place of r, I have put 2. So the case begins. When a is equal to 3q plus 2, on squaring both sides, remember it, you have to put the step. A squared is equal to 3q plus 2 whole square. Again, we are using the identity a plus b whole squared. A squared will be 3q whole squared plus 2ab, 2 into 3q into 2 plus 2 squared. 3q whole squared would be 9q squared. Then after plus, you just multiply the numbers 2, 3 and 2. 2 3s are 6, 6 2s are 12. 12q. And the last 2 squared will get converted into 4. 2 squared is 4. Then the next step, again remove the 1 from the entire numbers. You have to remove the 1. In special, the last 4, from the last 4, divide it, split it into 3 and 1. Why we split the 4 into 3 and 1? Again, visit the question. You see that the question demands 3m plus 1. So you need 1. Now, in the third step, there was 4. 1 was not there. How to get this 1? So there's only way to get 1 is to split 4 into 2 numbers, 3 plus 1. So 3 plus 1, you did it. You got 1. Remove it and keep it in the last outside the bracket. The stuff which is in the bracket is 9q squared plus 12q plus 3. Again, as in the previous section we did, remove 3 from this stuff and it will become common. So 3 is taken in the beginning, it is outside the bracket. Within the bracket, you see that you are divided the entire 9q squared plus 12q plus 3 by 3. So on dividing 9 by 3, you get 3. On dividing 12 by 3, you get 4. And on dividing 3 by 3, you get 1. And that 3 is kept outside the bracket. 1 already we have split 4 into 2 numbers, 3 and 1, and that 1 is kept outside. A squared is equal to 3. What is m? The stuff inside the bracket. And plus 1, you got whatever was the requirement of the question, 3m plus 1. So where m is equal to 3q squared plus 4q plus 1. Therefore, the square of any positive integer is either of the form 3m or 3m plus 1. This step is the last step which you have to write. Next question. Use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. The same method will be applicable which we saw in the previous slides. The same method. But here we are going to use the identity of cube. Let x be any positive integer, then it is of the form 3q or 3q plus 1 or 3q plus 2. This we have already discussed in the previous slide. We have applied Euclid's division lemma where r should be less than b. Here b is 3. So r can take three values. One is 0, another is 1, and the third is 2. R cannot be like 3q plus 3. Mind well, children, commit this mistake. R cannot be 3q plus 3. It should be less than 3. Start from 0. So 3q plus 0 is 3q, 3q plus 1, and then 3q plus 2. Not 3q plus 3. Because R should be less than B. So we have the following cases. Let's take the first case where x is equal to 3q. Then x cubed is equal to 3q cubed. That is equal to 27q cubed. 3q cubed is equal to 27q cubed. Now you take 9 common. 9 should be outside and the other stuff should be inside. 3q cubed. 9 is outside. Why? Because the question is demanding the form 9m. Visit the question and you will see that the question says it should be of the form 9m. That's why 9 is outside. Now don't confuse this with the previous question. In the previous question we had 3 common. Here usually students confuse and make 3 common over here because already you can see one 3 also over here. 3 is not common, 9 is common as the question demands 9m, not 3m in this particular question. So 9 is common, the remaining stuff is 3q cubed which is m and it is inside the bracket. Case 2. When x is equal to 3q plus 1, then x cubed is equal to 3q plus 1 whole cubed. Now this here we are using the identity a plus b whole cubed. That is a cubed. So first let me take stepwise. A cubed means 27q cubed. 3q cubed is 3 cubed is 3 3s are 9 3s are 27 and then q cubed. So a cubed plus 3ab squared. So 3 into a, that is 3q, into b squared, that is equal to 1 squared. So 3ab squared, that is 3q into 1 squared is 9q. Now next is 3a squared b. So that is 3 into a squared means 3 3s are 9, 9q squared, 9q squared into 3, 27q squared. And the last one is 1 cubed, that is 1. Now here we have to again remember, you visit the question wants you the form 9m plus 1. The question wants from you the form 9m plus 1. So in the last you are having that 1 should be outside the bracket. In the beginning 9 should be outside the bracket. And the remaining 3q squared plus 3q plus 1 should be within the bracket. Case 3. When x is equal to 3q plus 2, this is the last case, 3q plus 2, cubing both sides, then x cubed is equal to 3q plus 2 whole cubed. Now again you apply the identity a plus b whole cubed. 3q whole cubed is 3 3s are 9 3s are 27 whole cube. And then similarly 3ab squared and then a 3a squared b. 3a squared b, these are the identities used, and in the last one you have to use 2 cube, that is b cube. B cubed is 2 cube. So 2 2s are 4 2s are 8. The other calculations you do it in your rough work, you'll get 3a squared b and that will be 54 cube squared and then 3ab squared, right? You will do it in the rough work, you will get this calculation properly. Now again, what is the main step is you have to take 8 outside in the last. You have to remove 8 outside the bracket. Why? Let me explain to you. As the question demands, your form should be 9m plus 8. So last you need the number 8 and that number should be outside the bracket. In the beginning you need 9. So that again should be outside the bracket in the beginning. The remaining part is q is common. So the other stuff is inside the bracket. 3q squared plus 6q plus 4. So in the beginning you took 9. Your m is entire q into bracket 3q squared plus 6q plus 4, which is the entire stuff is m. And the last one is 8. The main thing you have to remember that you should take 9 outside and 8 outside the bracket. The other things in the bracket will do. We'll keep the entire thing inside the bracket, it will do. So m is equal to q into 3q squared plus 6q plus 4.